So I'm waiting for the recording notification. There it is. So let's talk about a few things here. First of all, let's go into Canvas. So I'm going to go into Canvas and I'm going to go into the student view. So this view looks like what you see. And I want to take a look at some announcements. I had a student in my Alex class yesterday request that I put up video links for the test 2 required written work topics. So here they are. So he particularly liked those video links. And you can see these are the test 2 written work required topics, and there are video links to each one of the 7 topics. So that may be a way that you choose to prepare. Those 7 written work required topics are worth 49 points of the grade, up to 49 points. So they're very important. We are going to go over those topics today. These videos are mostly from Arizona State University, who has a large global online ALEX program for their college algebra students. So they've been at this for quite some time, and they've done a really good job with their videos. I've watched many of them. So those are great resources for you. So let's go back to the announcements, but I want to remind you, the single most important part of the pre-check process right before you take your test is to get a clear picture of your government issued photo ID in order to avoid a testing violation. So I would encourage you to read that. You definitely want to slow down when you're taking a picture of your government issued photo ID. You do not want to get a violation. That is the most common violation that I give, is not getting a clear picture of your government issued photo ID. Some students don't present a photo ID at all, which is a violation. Some students present it, but it's blurry and I can't read it. So I encourage you to take a look at this announcement before you take the test. And don't forget, you're allowed to have this "How do I take my exam" test. You're allowed to have a copy of that announcement right by your side when you take your actual test. That will lead you through each step of the process. And then the last item I wanted to mention here is when you complete your test, you are required to upload the written work for the first 7 problems. To do so, you want to click on modules here, and then you will see upload exam 2 written work here. So that's where you want to go to upload your written work for exam 2. If you try to click on exam 1, you're going to get some kind of error message. This assignment was locked. It's not technically an error message, but it's a message. This assignment was locked February 9th at 5 p.m. So you know by what it says there, that's not the one to choose. I couldn't unpublish it. I wanted to unpublish upload exam 1 written work here, but I couldn't unpublish it. Canvas wouldn't let me do it. So any questions on these what I've said about Canvas? Okay, let's go on. Let's look at Alex. So I want to go into Alex, class tools, student view. This is Tuesday, Thursday. Just want to make sure that I'm in the correct class. So when you enter your screen today, this is most likely what you're going to see when you enter Alex today. So you will see that the test 2 review objective is due tomorrow at 11:59 p.m. You will see the test 2 review no credit assignment is due Thursday at 8 p.m. And then you will see this test 2 appears at 8 a.m. and disappears at 10 p.m. Upload your written work to Canvas for the first 7 questions. You should also see that when you click on assignments to start your test. I'm wanting to remind you as many different ways that I can not to forget to upload your written work for the first 7 questions. And that test is due at 10 p.m., which means it's going to disappear at 10 p.m. And it opens at 8 a.m. on Thursday. So you've got a lot of information there on your screen. Let's see what this notification is. Test 2 review credit is due Thursday at 8 p.m. That assignment is crucial, to be honest with you. If you want to do well in this class, it's really important that you do that assignment. Why? Because the first 7 questions in that assignment are the written work required topics. That's probably the most important reason to do that assignment. There's no way for me in the Alex software to indicate to it that those are your written work required topics. So I put them in this assignment. In addition, most of you are not going to see all of the topics, all 25 topics in the test 2 review objective, either because you've already learned those topics and you've continued to have a learned status for those topics. So when that happens, Alex isn't going to show them to you in the review objective. Or because you never opened those topics in the first place and learned them. You're also, then you're not going to see them. So most of you are not going to see all 25 topics, which is why it's very important that you do this test 2 review no credit assignment. Every student will see all 25 topics in that assignment. So I think that's what I want to say in terms of announcements or getting ready for the test. I just wanted to point all of those out for you in both Canvas and Alex. So let me come back to you all now. And does anybody have any questions? You're welcome at any time to put questions in the chat. So we are going to go over the 7 written work required topics, and please feel free to ask questions. Asking questions is probably the single best way to learn. No question is too small or too big. I don't judge you students on what questions they ask ever. It's not part of my personality. I grew up I grew up with a mom who was a teacher. Most all of my friends are teachers because it's just part of who I am. It's what I'm supposed to be doing. And my biggest objective is to see students learn. And if that means you ask small questions are really important, because asking a small question can mean that you can blossom and figure out the rest of the problem by yourself. So it's important to unmute your mic and ask questions, especially because you know you're going to see every one of these 7 written work required topics on test 2, and they are going to be the first 7 topics that you see.
Hey, I have a question about the review.
Yes.
If we do the review and then go back and do all the like modules, will we get all 25 topics on the review again? Like
No.
we'll load onto it or no?
No, because once you get credit for learning it, you are not going to see it in the test review objective.
Okay.
So it's automatically going to give you credit. In fact,
Okay, if we go back and we do the review like credit, and then we just go back and do all the modules that we missed before, we'll technically have all the points for it.
Yes, that's correct.
Okay.
That's correct. So that's how it works. Sometimes students say, I don't have any I can't find my review objective. And that's why. That's why they're not, because they got credit for all of them. Yes, so, but it's important, Austin, also to do that test one, test two, no credit assignment because of the written work topics, so you can practice them. Does that make sense? So the first 7 topics in that test 2 review no credit assignment are the written work required topics. So you want to make sure you're doing a few of each one of those just to see what the different variants are in those questions for the same topic. Does that make sense? So that's what you would, that's really what you should use that assignment for. If you do nothing else with that test 2 review no credit assignment, I would encourage you to practice 2 or 3 of each written work required topic, writing out the written work as you go. Because you might be asked, some of you might be asked to find a cube root, some of you might be asked to find a cube, for example. There's that much variance in the problems. So it's really a well worth your time to do that for those first 7 questions. Okay, well, speaking of the first 7 questions, does anybody else have any questions before we take a look at the first 7 questions? Let's go down to my desktop and feel free to unmute your mic and ask questions at any time. And even if we're in the middle of the problem, because it's very important, I want you to understand all the steps. What's different about the written work required topics, for the most part, is they tend to have more steps to them. So the very first written work required topic is writing the equation of a line through 2 given points. So you're going to be given the graph, and you want to write the equation of the line. So the first item of business that we need to do is figure out what the ordered pairs are associated with the 2 points that they make prominent to us. In other words, they're really showing us which 2 points they want us to use. And I would recommend using those 2 points and not other points on the graph, because this is how the ALEKS software has been programmed, with those 2 points. So the first point, you want the x coordinate, you go straight down to the x-axis to get it, and it turns out to be at -1. Then you want to go straight over to the y-axis, but it looks like this point is on the y-axis, and that would be at 2. So that's the y-coordinate. This point, straight down to the x-axis, that would be at 5. Straight over to the y-axis, that would be at 4. So the coordinates are 5, 4. Whereas this one is -1, 2. So this point here is at -1 and then 2 for the y coordinate. So we have our 2 points. So I just copied down those 2 points right here. And we're asked to find the equation of the line. Well, no matter how we find the equation of a line, we need to find its slope. So let's find the slope first. The slope formula, you definitely need to know that slope formula. So you might want to copy that down. The slope formula is y2 minus y1 over x2 minus x1. So what you want to do is you want to label your points. So I would recommend labeling them with x1, y1. I'm just trying to, I think this one would be x1, y1. This one would be x2, y2. Let's just go with that. So slope formula is right here, y2 minus y1 over x2 minus x1. So that's equal to y2. That would be this one, this y, which is 4. Minus sign. Y1 is this number, which is 2. Over x2, 5, minus x1, which is negative 1. So we need to figure this out. 4 minus 2 is 2. 5 minus a negative 1 is 5 plus 1, which is 6. You can take this 2 over 6 and put it into your graphing calculator. Do math, enter, enter. That will convert it to a fraction in lowest terms for you, which is 1/3. Otherwise, you could write this as, you can see that there's a 2 here. 6 is 3 times 2. If you cancel the 2's, you would get 1 over 3. You could write it out like that as 2. So ever how you want to reduce that, you want to make sure you're completely reducing your fractions. So what I can show you is this, just to show you how I actually write up test keys. I write it everything. So this 2 is really 2 times 1. Times 1. This 6 is 2 times 3. The 2's cancel. 2 divided by 2 is 1 times what's left is what's left, which is 1/3. So the slope is 1/3. Now we've got a point on our graph and we have the slope. So we're going to use point slope form. You could use slope intercept form here. There's no problem with that if you feel comfortable doing so. I'm going to use point slope form, which is y minus y1, y sub 1 equals the slope times x minus x sub 1. So y and x stay. So y stays. So y minus y sub 1. Y sub 1 is actually from this first point here, which is 2. 2 equals the slope. The slope we found to be 1/3. 1/3 times x minus x sub 1. That's from the x of this first point here, which is -1. So I put in -1 for this x sub 1 and got -1 here. So now we're ready to finish the problem. All equations of lines in math, we state in slope intercept form, which means we have to solve now for y. So the first thing I want to do is just copy the y minus 2 down on this side, copy this 1/3 down. X minus a minus 1 is x plus 1 right here. Now let's copy the y minus 2 down. I don't want to do too much in one step. I want to have my focus on one side or the other for now. So we wanted this is multiplication over addition. So let's distribute this 1/3 through. 1/3 times x is 1/3 x. This is positive times positive, so that's positive. 1/3 times 1 is 1/3. So now,
Where did the 1/3 come from?
it's the slope. It's the slope.
Oh, okay. Bad. I'm sorry.
Okay, no, that's fine. No problem at all. So it coming from over here, what the slope over here. Makes sense? So it comes from the slope, and then down here, you want to distribute this through. So we get 1/3 times x, which is 1/3 x, plus 1/3 times 1, which is 1/3. So all we have left to do now is solve for y, because we're required to write all of our answers in slope-intercept form, which is right over here. This is the answer. So we want to get y by itself. So the opposite of subtracting 2 is adding 2. So we want to add 2, can't just add 2 to the left side, we have to add it to the right side. So we get y minus 2 plus 2, minus 2 plus 2 is 0, y plus 0 is just y. We just get this y here. On this side, we get equals 1/3 x. And now we have to combine these two right here. So you want to have a way of combining these two, either by getting a common denominator or using, I don't know that the calculator is not available right here for this problem. So you want to make sure you know how to combine these two. So you want to, I would encourage you to have like a scientific, I would encourage you to have a graphing calculator, except I didn't want to make you have students go out and buy a TI calculator, but you need to be able to combine these. So for example, if I wanted to combine this, I want to write this 2 as in terms of thirds. So I want to know how many thirds is this number 2. So you can put we've got to get 3 in the denominator here. And the way to, but if we put it in the denominator, we also have to put it in the numerator. So I'm just focusing in on this 2 right here. That's that 2. This is 1 here. 3 divided by 3 is 1. 1 times 2 is still 2. Why did I choose the 3 to put in the denominator here? So I could match this 3 in the denominator. So I put 3 in the denominator first and then realize I've got to keep this at 1, which means I have to have the same number in both bottom and top. 3 divided by 3 is 1 times 2 is still 2. So this is still equal to 2. All of this is still equal to 2. But what that does for me is that helps me, that gives me a common denominator. And we'll use that in a moment. But first, let's work with this. This is really 2 times 3, which is 6. Which is 6 over 3. So what we're really talking about here is we're really talking, this 2 right here is 6 over 3. You can write the number 2 is 6 over 3. So writing this number as 6 over 3. And what does that allow us to do? We have 1/3 here plus 6/3. 1 plus 6 in the numerator is 7. 7 over what? 7 over 3. So we get plus 7 over 3 here. And that's how that's one way of getting 7 over 3 without a calculator. It's probably the best way to do it without a calculator. Anybody have any questions so far?
Do we have to do that on the written work? Like, do we have to put that step down?
I would. How else? How do you plan to figure out how to get the, say, the 7/3 here? What would you use to get the 7/3?
Well, if we just like know that the +2 would equal 7/3, can we just put that down like that the +2 just goes straight to it, or do we have to do the whole like 2
So let me
equals?
just say, if I were writing up an answer key, I have taught math and been doing math for so long. It's even relatively easy for math instructors to make an error by trying to do things without writing them out. So I would encourage you to write it out.
Okay.
Okay, but let's back up for a second. The other option is to check it. Like I'm going to show you how to check it now. Okay? So to answer your question, I would either write it out like this, possibly not check it, or I would make sure that if you didn't write it out, that you checked it. So for example, we want to make sure all points on our line have to satisfy whatever equation you write down. So let's pick one of the points. One of the points is over here. Let's pick -1, 2. So that means our x-coordinate is -1. So let's plug -1 in for our x-coordinate. And our y-coordinate is 2. Let's plug 2 in for our y-coordinate. Now what we want to see is, do we get a true statement or a false statement? If we get a true statement, we've likely got the correct equation. If we get a false statement, we've got an issue. So let's check. We know this entire side is equal to 2, so what we really need to do is check this side and see that we can prove that this right side is equal to 2. If we put -1 in for x here, we would have 1/3 times, we would have this 1/3, this is -1's going in for x, so we'd have 1/3 times -1 plus 7/3. Now, what is all of that going to give us? So this here, let's look at this term. This is positive times negative, which is negative. 1/3 times 1. 1/3 times 1 is 1/3. Plus this 7/3, just copied down. So now we have -1 plus 7. You can look at that in the numerator. That would be 6 in the numerator divided by 3. 6 divided by 3 is 2. 2 equals this 2 here equals, this is equal to 2 here. Let me just make it clear. Let me make sure I get this working again. Okay, I think that should work. This is equal to 2. So 2 equals 2 is a true statement. And we've checked one of our ordered pairs to ensure that we got the correct equation. Any questions on that? So that's another way to check. So you want some way to quick check your written work required topics because there's quite a lot going on in these. Any questions on this written work required topic? This math enter is a way to get a fraction on the TI graphing calculator. Let's take a look at this particular topic. Word problem involving average rate of change. So average rate of change is the slope. Rate of change is the slope. And whenever we say rate of change in college algebra, we mean average rate of change. So we're looking, this is a slope problem. Slope problem only, not an equation of a line problem, just slope problem only. So Dale is cooking a roast. I have a really pretty much lifelong friend, adult lifelong friend of mine who is a computer scientist. His name is Dale. Dale is cooking a roast, except he's a vegetarian, so that makes it funny. Dale is cooking a roast. The table below gives the temperature R of T of the roast in degrees Celsius at a few times T in minutes after he removed it from the oven. Part A wants us to find the average rate of change for the temperature from 0 minutes to 15 minutes. So this is what we call a T-table. You can make it one part of the T right down here, another part of the T right across here. A T-table just holds ordered pairs. A T-table is nothing more than a collection of ordered pairs. This is one ordered pair here, 0 for the T coordinate, 193.5 for the R of T, also known as the Y coordinate, if you will. So it's just a collection of ordered pairs. So what we need to do here is we need to find the average rate of change for the temperature from 0 minutes to 15 minutes. So we want to figure out where 0 and 15 are in our table. Here's 0 minutes. 0 minutes in our table is right there. 15 minutes is right beneath 0 minutes. So what we are going to be focusing on here are these two ordered pairs. The 0 minutes is right here in the 0 minutes column. In the minutes column, 0 is right here. 15 minutes, 15 is right here in the minutes column. These are their corresponding Y's. So I wrote down the two ordered pairs. 0, 193.5 right here. 15, 166.5 right here. And now we just have to find the slope. Label the first one with x1, y1, second point with x2, y2. So let's just find out what the slope is. Slope is y2 minus y1 over x2 minus x1, y2, 166.5 minus y1, 193.5 over x2, 15. And then minus x1. x1 is 0. And then I just used the calculator to figure out these numbers here. And the calculator is available in ALEKS for this problem. I got negative 27 over 15. They wanted that stated in what looks to be decimal form. I did not try to put it in fractional form, so I just found a decimal. Negative 27 divided by 15 on the calculator will give you negative 1.8. So the answer is negative 1.8. That's the average rate of change for the temperature. Negative 1.8 degree. Any questions on that? Negative 1.8 degrees Celsius per minute. So the next one, part B, it's all about identifying where 30 minutes is and 75 minutes is. So 30 minutes is right here. 75 minutes is right here. So this time the numbers aren't consecutive. So let's circle these numbers. So I think maybe I'd like to switch the color here. Just let's do the red and see if we, and let's look. So the first number we want to have for T is 30 minutes. 30 minutes right here. So here's 30. 30 is right here. So we want this one. That ordered pair. And then we want to, it's from 30 minutes to 75 minutes here. So we want 75 minutes, which is down here. Let's close that off. You can ignore the red dots, they're just part of the software. So we want the two red ones now. Ones have got partial red around it. So we want 30, 130.5, 30, 130.5. And we want 75, 22.5, 75, 22.5. And then we want to just put those through the slope find our slope just like we did before. So slope is y2 minus y1. So in this case, y2 is over here, 22.5 minus y1 is 130.5 over x2. X2 is 75 minus x1 is 30. X1 here is 30. Do this calculation, write it in decimal form and get negative 2.4. So that was the average rate of change for part B. Any questions on this particular topic? So let's go on. The third topic, writing equations of lines parallel and perpendicular. So we're talking about parallel and perpendicular lines, and the Alex graphing calculator is available for this problem. So you might want to practice with that, depending on what your calculator situation is. So we'll talk about both of these. So consider the line y equals 2/5 x plus 5. They've given us that equation in slope-intercept form so we can easily identify the slope of the line, which is this coefficient in front of x. The slope is 2/5. The slope of the given line is 2/5. We want to find the equation of the line that is perpendicular to this line and passes through this point. Also, we want to find the equation of the line that is parallel to the given line up here and passes through the same point. So let's do the equation of the perpendicular line first. Finding the slope of a perpendicular line is more difficult than finding the slope of a parallel line. Parallel lines have the same steepness and therefore the same slope, because slope is a measure of steepness, or you could call it a measure of grade, like driving up a mountain. There's a certain grade involved. So parallel lines have the same slope. To get the slope of a perpendicular line, you want to change the sign and flip it over. So here's our given equation. I just copied it down from up above. Y equals 2/5 x plus 5. The slope is this coefficient. Slope is a measure of steepness, and therefore it's a number. It doesn't involve x. The slope of the given line is this coefficient here, which is 2/5. Parallel lines have the same slope. So the slope of the parallel line that they're asking us to find is also 2/5. To find the slope of a perpendicular line, you want to start with this slope of 2/5. You want to change the sign. Change the sign. It's positive, it's going to change to negative. If this were negative, it would change to positive. But this is positive in our problem, so it changes to negative. And then we want to flip over the fraction. So I put the negative sign out in front because it makes it clearer when you flip over the fraction, just to keep that negative sign out front. So just copy over the sign, take the 2/5, flip it over to get 5/2. So that's the slope of our perpendicular line. So our perpendicular line, we are told both our perpendicular and our parallel line go through the point, the same exact point of -4, 3. So I copied down our point here, -4, 3. Our slope for our perpendicular line is -5/2. Right, I copied that down. Point slope form of the equation of a line. Want to make sure you're writing that formula down on the test. Y minus y1 equals the slope times x minus x1. So we want to start plugging in here. So we're going to plug in. So this is our formula. We have y minus y1. I labeled this point x1, y1. Y1 is 3. So I will put in 3 here because we want to put in y1. So I put in 3. Equals the slope, which is -5/2, times x minus x sub 1. X sub 1 is -4. So this is what we are working with. We've got y minus 3 equals -5/2. So I copied down the y minus 3, copied down the -5/2. X minus a minus is x plus 4. And then I'm going up here. Copied over the y minus 3 here. This is multiplication over addition, so we can distribute the -5/2 through. -5/2 times x is -5/2 x. Negative times positive is negative. So this would be -5/2 times 4. -5/2 times 4. Right there. So what do we get? We get y minus 3. So now we have this. So what we want to do is clean up this side a little bit. Just copy this over. Copy this first term here, this -5/2 x over. So this is now -5 times 4, which is 20, divided by 2, which is 10. But we have a negative right there. So this is -10. So we want to solve this for y because we want to write our equation in slope-intercept form. So we are required to solve for y. So we need to move this -3, the opposite of subtracting 3, adding 3. So let's add 3 to both sides. -3 plus 3 is 0, plus y is just y. So on this side, we get -5/2 x, -5/2 x. You don't have to write it in parentheses like this. I just did that for a reason, because I want to check. -10 plus 3 Negative 10 plus 3 is negative 7. So this is the equation. Y equals negative 5 halves x minus 7. So maybe what I should do is let me make sure, just give me one moment here. Yeah, I got to remember lots of little things to think about here. Let's take off these blue. I don't want these blue right here to confuse anybody. This is the answer right there. Y equals negative 5 halves x minus 7. Now I think it's very important that you check a point. It's a lot of calculations there, a lot of little details. It's important to check. So what point do we want to check? This point right up here. We've got a point to check right here, negative 4, 3. This point must satisfy our equation or we've done something wrong. So let's put in for y, let's put in 3. Let's put in 3 for y. Let's put in negative 4 for x, and you can see I did that. So I put 3 in for y, then I wrote down on this side the negative 5 halves x, put in this negative 4 here for x. I put in that negative 4 for x, and then minus 7. So you want to make sure that you can make now the left side equal the right side. So what do we have here? We have negative times negative, which is positive. We've got negative times negative, which is positive there. So this is positive. And what else do we have? We've got 5 times 4, which is 20, divided by 2, which is 10, minus 7, which is 3, and that checks out. So this is the equation of the perpendicular line that this problem was looking for. So now the parallel line works exactly the same way, except it's a bit easier because what we're using for the slope of the parallel line is just this 2/5. Parallel lines have the same slope, so we're using 2/5 in that case. We're still using the same exact point that we used, which was negative 4, 3. So we're using that point negative 4, 3, and we're using the slope of the given line because parallel lines have the same slope. We're still using this point slope formula, and let's plug in. Y minus y1 is 3. So we get y minus 3 equals the slope, which is this 2/5 here, x minus x sub 1, which is minus 4. So that's x minus a minus 4. Copy this down, copy the slope down. Minus a minus 4 is a plus 4, so we get x plus 4 in here. And then we want to copy this down, multiplication over addition. We want to distribute 2/5 x. This is this is positive times positive is positive. 2 times 4 is 8, divided by 5 from this right here. Now we just have to move this minus 3, add 3 to both sides to do that. That's the opposite of subtraction is addition. Add 3 to both sides. And what do we get? These cancel. So we just get y equals 2/5 x. Just copy that down. And here we have 8/5 plus 3. Got to find a way to combine them. So one such way to combine them is this. So let's just write it out, since that would work for students that don't have a calculator that can do this. So I'm going to take this 8/5. Now this 3 I want plus 3. Plus this number 3. We want to convert it to fifths. We want to convert it to fifths. So we want to 5 in the denominator because it's easy to add when we have like denominators. But we can't just put 5 in the denominator. We've got to put it in the numerator as well. So that 5 divided by 5 is 1. Times 3 is still 3. And we're really not changing this term here. It's still, it's still, this entire term still is 3 because it's 3 times 1, which is 3. But converting it like this allows us to add. So this is 8 fifths. 3 times 5 is 15 fifths. So this is 8 fifths plus 3 times 5, which is 15 fifths, now we just have to add the numerators. 8 plus 15, so 15 plus 8 is 23 fifths. And that's what this part of this problem is, 23 fifths added on at the end here. So the answer is y equals 2 fifths x plus 23 fifths. I would encourage you to check, but I'm not, in the interest of time, I don't really have time to check every one of these problems. Any questions on parallel and perpendicular lines? Let's take a look at this problem. This problem is writing an equation and drawing its graph to model a real world situation. Caitlin is driving on the highway. She begins the trip with 12 gallons of gas in her car. The car uses up 1 gallon of gas every 20 miles. And you will notice these problems are different than what I presented originally in the course. They're the same topics. We've seen these topics before, but they're a little different now in terms of the questions. So let G, capital G, represent the number of gallons of gas she has left in her tank, and let capital D represent the total distance in miles she has traveled. Write an equation relating G to D, and then graph your equation using the axes below. Well, graphing in ALEKS isn't difficult once you know the points that you want to plot. So that isn't the issue. So let's think about what we want here. I would always be very careful here. You might even want to go so far as to do this. It depends how comfortable you are working with different variables. You might want to temporarily put y on this axis and x on this axis. But ALEKS is not going to give you the correct answer. Let me see if I can get this y to go up just a bit more. Yeah. In order to get the correct answer in ALEKS, you definitely want to convert to the variables that they give you. In this case, they give the y is in this problem is G. You want to use G, and the x is D. You want to use D. So G is the number of gallons of gas left in the tank. D is the distance. So I would start with always choosing 0 for, in this case, D. Whatever the variable is on the x-axis, I would choose 0 for that. So I chose 0. What does that 0 mean or represent? What does D represent? Let D represent the total distance in miles. If D is 0, Caitlin is still sitting in her garage. Her car is still in her garage if D is 0. That means we want to find what the G is. That's the number of gallons she has left in her tank. She begins the trip with 12 gallons. She has, if her car is still in the garage, all 12 gallons are still in that tank, which is why this is 12. So that's one ordered pair. The next ordered pair. Let's read this. She begins the trip with 12 gallons of gas in her car. The car uses up 1 gallon of gas every 20 miles. I picked 20 for the next distance because it's related to using up 1 gallon of gas. Easy to work with. 20. So 20 is the next. 20 miles is at the next place that she's using up 1 gallon of gas. So I put 20 in here. So if she goes 20 miles, she's using up 1 gallon of gas. She started her trip with 12 gallons. She's now gone 20, the exact number of miles she needs to go to use up 1 gallon. So this 12 goes down to 11 now. And that's why I have an 11 here. So those are 2 ordered pairs you can plot using the ALEKS software, and then draw a line, but use the line tool to draw a line between them. So that's that we need to draw the graph, but we also need to write this equation. So let's write the equation. The first thing we need to do, no matter how we write an equation or go about it, is we need to find the slope. So I labeled this as x1, y1. This is x2, y2. The slope is y2 minus y1 over x2 minus x1. Y2, 11. 11 minus y1. Y1 is 12 over x2, 20 minus x1, 0. So this is 11 minus 12, which is -1. 20 minus 0 is 20, -1/20. So this one you can get away with y equals mx plus b. Y equals mx plus b. We know what the b is. The b is the y-intercept. We know that's the y-intercept occurs where x is 0. That y-intercept is 12. So we know what the y-intercept is. What we can put in for b, it's 12. We know our slope. It's -1/20. Now this right here is where we have to be very careful. You don't want to write in your equation in ALEKS as y with y and x. You want to use the variables that they gave us. On the x-axis, what we think of as x, it's d in this case. It's d, capital D. So you want to take out x, put in capital D. What's on what we think of as the y-axis is this g. for gallons, this capital G. So we want to take out the Y and make sure we're replacing it with G before we type in the answer. So that's something you want to watch out for. So this is the answer, and then you can use the Alex software to graph. Any questions on this particular topic?
How did you get the 12 as plus 12 at the end?
The plus 12, it's because that's right here. So this is 0, 12. Do you understand why we got 12 here, up here?
Is it because of 12 gallons?
Yes, yes.
Okay.
Does that make sense?
Yes, thank you.
You're welcome. Any other questions? So this is our y-intercept right here. Because all y-intercepts have an x-coordinate of 0. Anything on this y-axis here, I can trace down to the x-axis and it will give me an x-coordinate of 0. Any other questions? Good questions. So next we have a difference quotient problem. So let's take a look at the difference quotient problem. So we've looked at the first 4. We've now got 3 more to take a look at. So we want to find the difference quotient, f of x plus h. Really, this is f of x plus a tiny bit more is how we view it in calculus. So this is finding f of x plus a little bit more, which we call h, that little bit more. So f of that, we want to find the difference quotient f of x plus h minus f of x divided by h. And of course, this h that we're dividing by can't be 0. We're not allowed division by 0. So that's why we're excluding h. We want to find h that's not equal to 0. That's why there's this exclusion here. H can't be 0. But h is just a little bit more. H is always positive, and it's just a little bit more. It's a little positive. It's positive, but just by a little bit. Where h is not equal to 0 for the function below. Here's our function. F of x equals negative 2x squared plus 6x minus 3. Now, the very first thing, this is what we're trying to find. And we want to use this rule, if you will, to find it. So what I would recommend is these x's are just shorthand for the word input. This x is an input, this x is an input, this x is an input. If I were you, I would take and write this over again. For every x, I would actually write out the word input. So this would be f of input like this equals negative 2. Here's x again. I would write out the word input, put it in parentheses, and then square this x, or square this x, yes. Take the x and write x squared. So I would write negative 2. This x is just the word input. Put that x in parentheses and then square it like this. And then add plus sign 6. Here's another x. We're going to take that out and put in the word input for it. Input in parentheses like that. And then minus 3. I think this is a whole lot easier to work with now that it's written like this. There are x's in this and x's in this. It makes it too confusing. So we are now going to break this job down. We want to find the difference quotient. We're first going to find just f of this x plus h. So that means now when we find just f of x plus h, our inputs, what's in parentheses here, which is x plus h. That means we are putting in x plus h for this and this. So when we we copied just f of x plus h down like this, and I want to see your work labeled like this, equals, it would be -2 from here. And then we have input. What is our input? Our input is what sits right here. It's x plus h. And then we want to take that x plus h and square it. Square it. So this would be x plus h squared here. And then plus 6. So you're plugging it into this formula up here, if you will. Plus 6. Plus 6. And then we see the word input. Our input is right what's inside here, x plus h. So we're putting x plus h in for this input. And that will give us 6 times x plus h minus this 3. And we want to work with this for a while. In particularly, we want to work with this. This too is mathematicians' way of stating repeated multiplication. What we want to do is take 2 of these x plus h's, 2 of them, in other words, x plus h times x plus h, and multiply them together like this. Now we can FOIL that. First 2, x times x is x squared. Outer 2, xh. Inner 2, hx, but we can switch that to xh. So we have xh plus xh, which is 2xh. And last 2, h times h is h squared.
I have a question.
Yes.
So I know how you get the x squared and the hx, or the h squared, but I don't know how you get the 2xh. Can you explain it?
So do you understand FOIL, what FOIL means when you first, outer, inner, last?
Yes.
Okay, so let me just kind of mark this up a little bit. So the outer 2 here, that's these guys. Those are the outer 2. Okay? The inner 2, that's these guys. Those are the inner 2. So what do we have? The outer 2 gave us x times h. Can you turn down your mic, please? So we've got xh from the outer 2. From the inner 2, we have hx. Does that make sense?
Yeah.
Now you can switch the order you multiply. Multiplication's commutative. This is multiplication. So is this. It doesn't matter which order we multiply. 5 times 3 is the same as 3 times 5. You give the same answer. So we can take one of these and switch this order. We can write this one as x times h. So now we've got xh plus xh. We have 2 of them. That gives us 2xh right here. Does that make sense?
Yes, thank you.
You're welcome. So let's go back up here. So now we have -2. We are going to take this out and replace it by, in parentheses, we want it all in parentheses, x squared plus 2xh plus h squared. And then we're just going to copy down this plus 6 times the quantity x plus h minus this 3. And we're going to distribute. This is multiplication here over addition. This is multiplication over addition, so we're just going to distribute. Negative 2x squared goes right there. Negative times positive is, of course, negative. Negative. So 2 times 2 is 4. And then x. And then h from in here. X, h. And then we have negative times positive here. So that's going to be a negative. And it's going to be a 2 from here. And an h squared from inside. And then plus 6x plus 6 times h, and everything's nice and positive, so that's 6h minus this 3. So there's really no like terms here. Like terms have the same variables to the same exponents. There's no like terms at all to combine here. So we just have to live with this for now. So we've done the hardest part, the f of x plus h. The next part that we want to find is this f of x here, minus f of x. We want to subtract off minus f of x. So we wanted, I just copied down, we had f of x plus h, and then subtract off f of x, because that is what this up here is telling me to do. Subtract off f of x. Now, subtracting off f of x, that means we have to copy all of this over again. So I copied all of that over again. It's ending at the negative 3 here. And then we would need to subtract off f of x. What's f of x? F of x is just this, what's given right here. It's negative 2x squared plus 6x minus 3. Negative 2x squared plus 6x minus 3. So if you take a look here, you can distribute this negative sign all the way through, but it takes a lot more writing though. So what I would look at here is you want to look at this. So this is, let's look at this one. There's really, this is negative 3, but there's really a negative outside. So it's negative of a negative 3, which is a positive 3. But you have a negative 3 here, so that's going to cancel that negative 3. This right here is really got a negative sign out in front that's getting distributed through, so that's really negative 6x. But there's a positive 6x here, so those cancel. This is negative times negative, which is a positive 2x squared. So we have positive 2x squared, but way back here we have minus 2x squared. So positive 2x squared minus 2x squared cancel. So I canceled all of those. So what's left? What's left is this term, and this term. Note that this term has an h in it. Note that this term has an h in it. This h squared means you really have that this is negative, this can be written as negative 2h times h. We've really got 2 h's here. We certainly have one. And then this term has an h in it. Every term that's left has an h in it. So let's factor the h out front. If we take the h out front, what's left here is the negative 4x inside. Here we have negative 2. This is h times h, so h squared. Exponents are mathematicians' way of stating repeated multiplication. So this is really h times h. H times h. That's what h squared represents, h times h. h times a. So we want to, one of those h's is going all the way out front, but only one. So there's this -2 left inside, and one of these h's is left inside. And then we've got down here 6h. The h went out front. The +6 is staying on the inside. So we've simplified f of x plus h here minus f of x as much as we possibly can. The last step now is to divide by this h right here. So I now wrote this down in the numerator, divided by h. Just took and copied all of this down in the numerator, divided by h. H divided by h is 1. And 1 times what's left is just what's left, which is -4x minus 2h plus 6, which is indeed the answer. This is the answer right here. Any questions on that problem? I know there's a lot going on there, but this does come up in survey of calculus. In fact, my students are taking a test tomorrow, and they are having one of these on their test. So it does come up. Any questions on this? Let's take a look at the quotient of two functions basic. Just check. And we've got this one and another one to do. Suppose that functions h and g are defined as follows. H of x equals x minus 8. G of x equals x minus 5 times x plus 3. Part A, find h divided by g at the number -2. Let's do that one first. So h divided by g at the number -2. So part A, h divided by g at the number -2. Now the reason why this -2 is only written once, it probably should be written twice, but they didn't want to make it look like h divided by g of -2 divided by -2, because that would be confusing. You would probably just want to cross out those -2's. So this notation really means they want you to find h, the function h at x equals -2, and they want you to find the function g at -2. That's what that notation really means. So let's find the y value of the h function when x is equal to -2. Here's our h function. So when x is equal to -2, we want to take this -2, plug it in for x there, and we will get -2 minus 8. -2 minus 8. And then g of -2. In other words, what's the y coordinate of the g function when x is equal to -2? So we want to go to the g function and plug in -2 for x. So this would be -2 minus 5. -2 minus 5. Right here, -2 minus 5. And then we're going to plug in -2 for this x as well and get -2 plus 3. -2 plus 3. And all we need to do is calculate that. -2 minus 8 is -10. -10. Negative 2 minus 5, that's negative 7. Negative 2 plus 3 is positive 1. So what do we have? We've got negative 10 over negative 7 times 1, which is negative 7. Negative over a negative is a positive. 10 over 7 is 10 sevenths. The answer is 10 sevenths for part A. Any questions on part A? Part B is a little different. In part B, find all values that are not in the domain of h divided by g. If there is more than one value, separate them with commas. So rather than having you write the domain out in interval notation, which we sometimes do, there's another way to give us information about the domain. That's just by, sometimes we just want to know which values are not in the domain. And then we just assume all the rest of them are. So that's what's going on in this case. So we want to find all values that are not in the domain of h divided by g. So h divided by g. H divided by g means h of x divided by g of x. And what we can't have is division by 0. It's okay to have what kind of function is, let me take a look at h. H is just a linear function. It's okay to have a linear function in the numerator. That's not going to cause us an issue. What's going to cause us an issue is dividing by 0. We don't want that. Those numbers aren't in our domain. Whatever causes division, but those x's that cause division by 0 aren't in our domain. A domain is a set of all numbers for which the original function makes sense. Division by 0 doesn't make sense. So we're looking for the numbers that cause division by 0, and we want to throw them out. So it's okay, whatever we have in the numerator is okay in this context. We just need to look to see where the denominator, the entire denominator is 0. Cannot have division by 0. Cannot ever have a denominator, the entire denominator. We cannot ever have the entire denominator be 0. So let's take a look at this g of x. This potentially could cause division by 0 here, depending on what g of x is. And g of x in this setting is x minus 5 times x plus 3. So we want to take x minus 5 times x plus 3 and set it equal to 0. And see if it gives us any values that will cause division by 0. So the way we handle this represents a real number, does this. So how do we solve this kind of equation? Well, the only way we can get this real number times this real number to be 0 is if one of these or the other is 0. So we're going to find where x minus 5 equals 0. So x minus 5 equals 0. If we solve that equation, the opposite of subtraction is addition. Let's add 5 to both sides. So we're going to get just x on this side because negative 5 plus 5 is 0 and x plus 0 is just x. On this side, we get 0 plus 5, which is 5. So x equals 5. 5 causes division by 0. 5 minus 5 is 0 times whatever this is 0. That's going to make that entire denominator 0. Let's set this factor equal to 0. X plus 3 equals 0. If we solve this, the opposite of adding 3 is subtracting 3. That's going to just leave x on this side. 0 minus 3 is negative 3. So we can't have these two values. Right here, I just copied over this x equals 5 here, and this x equals negative 3 here. So we want to make sure we're excluding those values because they cause division by 0. And we should be able to check those. So here's our g function up here. If we check this 5, for example, in the g function, our entire denominator is the g function. Our entire denominator is the g function. So if we check this 5 up here in the entire g function, we get this x here is 5. So we check it here. 5 minus 5 is 0 times what's left is 0. That definitely caused division by 0. So we just state it as not being in the domain. This negative 3, if we plug negative 3 in here, we get negative 3 plus 3, which is 0, times this is still 0. So that negative 3, it causes division by 0 as well. So we're just excluding the values here that cause division by 0. That's one way to approach looking at a domain, by excluding the values that aren't in the domain. Any questions on this particular topic? So let's take a look at this last topic of the day, and I want to make a comment. There are different variants of this problem. Here, we are asked to find the inverse of a cube root function. Sometimes sometimes the same topic will give you to find the problem, find the inverse of a cubic function, not a cube root function, but of a cubic function. So I would encourage you to make sure you're doing a couple of each of those, because you could see those different variants on the test. And when I grade, I tend to see about even distribution among the students that get the cube root versus the cube to start with. So let's take a look at this one. The one-to-one function is defined below. One-to-one functions are the only functions that have inverses, which are functions. So let's go through the process. I just copied this function right here. We want to find the inverse of this given function. Inverses have unique properties. If you compose them in either direction, you're going to get back to where you start. You're going to get the exact value that you started with. If you compose them. In other words, you apply the cube root, then you apply the cube, or you apply the cube, then you apply the cube root. You're going to get exactly back the x that you start with. So let's start here. I just copied this down. How do we find the inverse? We're asked to find f to the negative 1. That negative 1 doesn't represent, that just represents the word inverse. It represents this word. That's all that negative 1 up there does. There's no math involved. It's not a reciprocal or anything like that. It just represents the word inverse. So here are the steps, and you might want to jot these steps down. I just copied over the problem. The first step is to replace f of x by y. So we're going to take out this f of x notation. We're going to replace it by y. And then just copy this down. This is the most important step of all. You want to replace the y by x and the x by y, because when we find inverses, the x becomes y and the y becomes x. So we're going to take the y and replace it by x. We're going to take the x and replace it by y. And that's all we've done in this step. Then we want to solve for y. So the first thing I see, y is underneath the cube root here. Let's move this 4. The opposite of adding is subtracting 4, so let's subtract 4 from both sides. On this side, we have x minus 4. X minus 4 equals cube root of y minus 9. Copied down here, 4 minus 4 is 0. Plus 0 doesn't add any contribution, so we don't need to write it in. Now this is a cube root. This cube is down in this root a little bit. It's called the cube root. The opposite of cube rooting is cubing. The opposite of cubing is cube rooting. So we want to cube both sides, which means we want to put parentheses around both sides and then raise it to the third power. So we're going to raise it to the third power here and here. So 3 here, the third power. So what do we have? We're just going to copy this over. Cubing undoes cube rooting. So all we get left after that is just this, what's inside the root, which is y minus 9. And now, what do we want to do? We want to solve for y. So we need to continue to solve for y. All we need to do is move this minus 9. The opposite of subtraction is addition. Let's add 9 to both sides. On this side, we get x minus 4 cubed plus 9 equals y. Minus 9 plus 9 is 0. Y plus 0 is still y. And lastly, the last step is to replace y by this inverse notation, by f inverse of x. So we replace the y, this y, by f inverse of x. We usually write that on the left side. That's equal to all of this that I put on the right side over here. And that is the answer. Any questions on this particular topic? And it can be a little, this one, you can see different variants. And I think we've got a little bit of time left, so let me just go and see if I can get.
Can I see that for one more second?
Yeah, just one second. Let me just kind of pull up something else and then I'll go back to it because I was kind of in the middle of something. Yeah, there you go. So,
okay, thank you.
You're welcome. So just to show you what a variant might look like, this is the one I did in class recently. And let me just go. Let's see if I can find them. I'm not sure exactly what order. Okay, so there's a cube root one, which we just did. There's another one. And I'm trying to, yeah, and also you see here, this one, they gave us a cube root to start. This one, they gave us a cubic function to start with. So I really want to encourage you to look closely at that when you're looking at that test to review no credit assignment. And one more thing I want to point out. you're solving for y in these problems, I wouldn't leave something a negative y here, because you're having to deal with how do you deal with that, and then you're moving over with the 7 and you've got something else on this side. I would encourage you, for me personally, I prefer the y to be positive, working with it from a positive point of view. So I make it positive. I get it to be positive by adding y to both sides in this situation. So I'd encourage you to do the same thing, because otherwise you may end up with the wrong sign in front of this expression right here. So I don't want to take time to go over that because we're running pretty short on time now, and this was the last topic I wanted to go over with you all as the written work required topic. I find they take almost the entire class period. So I want to come back up to you all, and I want to ask the question of the day now, and I'm going to put that in the chat, and this is the participation requirement for today. And let me type that into the chat. How will you, or how do you plan to, how do you plan to prepare for test 2? How do you plan to prepare for test 2? That is the question today for participation. What does the test 2 no credit assignment, how does that come into play for you? The study, the review. Are you talking about the, oh, are y'all, you, I see, yes, yes. Great. I'm loving this. Oh, that's good, Austin and Matthew and Madison and Stephanie P. I love it. Good, Miriam. I'm like, I need to get my pom-poms out and cheer for all of you because I want you all to do well. Good, Alejandro. Love that you're going to look over your notes, Skylar, and doing the review and past objectives. Caitlin, do you know how to get the lectures? I think I showed you that earlier today. Do you know how to get to the lectures? By going into Canvas and going into modules and scrolling all the way down to get to the videos? So that's how good, Caitlin, that I see your answer to the question. Very good. Is there a study group tomorrow? Alejandro, are you up for a study group or? Austin, you're more than welcome to meet with me. Yeah, okay, Alejandro. We can make one,
Wait,
Alejandro says.
can I meet with you tomorrow, Miss Ann?
Sure, or do you want to meet with Alejandro and company?
Because the ones I'm stuck on is the piecewise for the past objectives and the one from yesterday. I don't
Do
know
you
what it's.
do it right after class today?
Yeah, I could do one of them.
You sure?
Yes.
So I think they want to try to find a time to meet in a study group. Let's see what time it is. It's 1:42. So we have a little bit of time left in class, and those of you who want to work on me trying to come up with a time to meet, feel free, but let me go over that piecewise defined function one, Matthew, okay? Because there may be others who want to see that too. So I have already prepared, I already have that up to take a look at. So you're talking about this problem right here, right?
Yes.
So let's take a look at this. So do you have any specific questions on this?
Well, I mean, I guess I just don't understand it in general.
Okay, so there are quite a few steps to this, and let's do this one. I've got it marked up more. There are quite a few steps to it, so make sure you ask questions because it's important to understand every little detail here. So it's very detailed, but these do come up. So graphing a piecewise defined function, problem type 2. Now this is what's given to you over here initially. I've got it a little bit marked up. This is what's given to you initially. So maybe what I should do is I should unmark it up so you can see what's given to you initially. So it's not so cluttered. So let me get this off, and this off, and this off. And let me just check on something here. Yeah, good. I'm glad. For a moment there, I thought I didn't have the recording on. So this is what's given to you. Right there. Along with the directions, suppose that the function f is defined for all real numbers as follows. Graph the function f, then determine whether or not the function is continuous. So this f of x here represents the y coordinate. This is y equals. Y equals x minus 3, but only for the x coordinates which are less than or equal to -2. However, y equals this, 4x plus 5, if the x coordinate you're talking about is bigger than -2. So this column right here, I would consider this to be your rule column. This column here is considered to be your domain column. The domain is the set of all x's. It's where all knowing the math terminology comes in. The domain is the set of all x's. And the reason why I have first up here, because you always want to look at this first. You always want to figure out if your input, your x, satisfies this rule or this, or sorry, if your x satisfies this inequality or this inequality. It's not going to satisfy both. It's going to satisfy one or the other. And there's different variants of this as well. So where do we go from here? So where we go from here is this number is different in the different problems, but this number is the same here. -2 and -2. You're not always going to see -2 and -2 here. You're going to see different variants. And this is another reason why that test 2 review no credit assignment is so critical, is because it's going to show you more variants like you would see on the test. I did not create the test from the artificial intelligence portion of ALEKS. I created the test the same place as I recreated your test 2 review no credit assignment. So the variants are likely to be more accurate when you look at the test 2 review no credit assignment. So the first thing I would do is this is y equals m, this is in y equals mx plus b form because your slope is 1 here. Understood to be 1. This is in y equals mx plus b form as well. So we're really talking about graphing pieces of lines. So we only need 2 points on each piece because 2 points determine a line. So I've got these little t-tables that I wrote down here and here. For this first piece right here, this is the t-table for the top piece. For this piece, straight over here is the t-table. So I took this -2 here and I put it in both t-tables, -2, -2. There's a reason for that. If students who don't do that tend to miss out on get part of the graph wrong because they didn't consider that. So you want to make sure you're putting whatever this number is over here in both t-tables, -2 here and here. If this were -5, you'd want to put -5 here and here. Then you want to make sure that whatever else you choose for the t-table satisfies this inequality. So for the top piece here, you want to choose a number which is smaller than or equal to -2. We don't want to choose -2 again. You want to choose a number that's smaller than -2, which would be, if you go back towards infinity, that would be -3. And here, you want to choose another number besides -2. And there's a reason why we've got a circle there. We'll talk about that in a moment. Another number other than -2. We want a number which is bigger than -2. The logical one would be 0. Very easy to work with. So now, why are some of these colored in? These 3 colored in, and this one is just a circle. It has to do with which satisfies, whether the x satisfies the domain or not. If I put -2 in for x here, -2 is less than or equal to -2. That is a true statement. So -2 go in here, less than or equal to -2 is a true statement. That's why I colored in. This is colored in here. And it doesn't look like this. Because this -2 satisfies this top rule, which is what we want it to do. Okay, satisfies the top rule because this is the t-table for the top rule. So now we put in -3. -3 is less than or equal to -2. That is a true statement. So we color this in. We don't leave it as an open circle. We color it in. And all circles are open, by the way. They're never colored in. The circle is just that, the circumference. So then we need to fill out the rest of the t-table. So how do we do it? We put -2 to get the y-coordinate. The y-coordinate is right here. The y equals x minus 3. For this top t-table, the y, we can find the y by using the top rule. We've got it set up that way. So y equals x minus 3. And you see I have that written above here. So to find our y, we just take each x here, -2, plug it in here. -2 minus this 3 is -5. -3 plugged in here, minus 3 is -6. So that's where those ordered pairs come from. Down here, any questions on how I got this t-table?
So how you got -5 and -6 is you plugged in the -2, but where'd you get the -2 from?
The -2, you have to select -2 because -2's appear here and here. So we need to put -2 in both of these t-tables.
And the -3 came from the left side too?
-3, you just need to choose any other x here that is smaller than or equal to -2.
Okay.
Okay, that's a great question. So this t-table right here just corresponds to this the top rule and condition here for x. So this table corresponds to this top rule and domain here, if you will. Now this t-table corresponds to the bottom rule and domain down here. Now this is a circle. Why is it a circle? Because if I put -2 in here, this x, -2 for x, get -2 greater than -2, it's a false statement. That's why this is a circle. It's not a colored in dot, it's a circle. But we get ever so close to -2. We get infinitesimally so close to -2, we really need to include this in our table, to be honest with you. You likely won't get the right answer, the right graph if you don't. And then we want one other number that satisfies this inequality. We want to choose an x which satisfies this inequality. We want to choose a number which is bigger than -2. 0 makes a lot of sense. So this is a 0 here. This is a circle here. So this is 0 right here. You could choose 1 if you wanted to. Maybe that's the confusion. Maybe we could choose 1 if that's confusing. Let's leave it as 0 though. It's easy to work with. So for the bottom rule and domain, we want to use this rule. F of x equals 4x plus 5. We've got 4x, so that would be f of x, we could call that y equals 4x plus 5. So now we just plug in -2. We plug it in for x, we get 4 times -2, like this, plus this 5. 4 times -2 is -8, plus 5 is -3. And then we want to plug in our 0. 4 times 0 is 0, plus 5 is 5. Any questions so far? So I think
No, not right.
What did you say?
Oh no, not right now. I'm just.
Okay.
Well, I am wondering about the circle on the left side. Why is it not cleared in?
The circle on the left side.
Oh, where it says -2, like on the.
Right here?
Yeah.
Because if I put in -2 here for x, I get -2 greater than -2. It does not satisfy that. But
okay.
The problem is the graph gets ever so close to it that we really need to do this. Okay?
Okay.
Any other questions?
No, not right now.
Okay. So now let's graph. So let's plot these points right here, -2, -5, and then make a colored in dot so we know where it is. -2, -5. So start at 0, go to -2 here, -1, -2, and then go down to -5. Negative 5 would be right there. So that would be colored in. We want it, and it told us to color it in right here. So that's colored in dot. Negative 2, negative 5. Next, negative 3, negative 6. Start at 0, go to negative 3, negative 1, 2, 3, down to negative 6 would be right here. And that's a colored in dot as well, this one right here. So when you're starting the graphing process, how do you know whether you go this direction or this direction when you draw the line, part of the line through these dots? Well, that's where this domain comes in. So the domain of this top piece is x less than or equal to negative 2. So x less than or equal to negative 2. And you can all leave, feel free to leave because it's after time if you want to, but you feel free to stick around as well if you want to hear this and you have time. Okay, so what I want to do is...
Have a good day.
Yeah, bye-bye. Bye. So what I want to do with this top, we're focusing on this top rule here. You notice the domain here is x less than or equal to negative 2. X less than or equal to negative 2. X less than or equal to negative 2 is right here. That's, if I draw that domain on the x-axis, that's where it is. So I've got this point and this point now, but the question is, do I want to connect those 2 points and go this way? Or do I want to connect these 2 points and go this way? The answer, go this way, because this way I can trace all of these numbers, these x's up to the x-axis, and I can see that it's where I just drew the domain, this red domain here on the x-axis. Does that make some sense?
Yes, a little bit.
Okay, so now I'm going to take that off because I don't want it to confuse us. That's just was to help us draw it the right way. So now we have this piece of our graph. It's a ray that goes on forever in this direction.
Okay.
So now the other graph, or the other t-table. Let's take a look at that. We want to plot this point, negative 2, negative 3. So we start at the origin, negative 2, negative 1, 2, and then negative 3 is right down here where this circle is. And we are not going to, and then we're going to plot this point, 0, 5. 0, 5, here's 0, here's 5. We've got, and that's a colored in dot, if you will. Now we can't go this direction because if we did, we'd cross that part of the graph. And that would violate the vertical line test for a function, and we have a function. We have to go this direction now. And I didn't mean to get that point there. We have to go this direction now because that's the only other direction we can go. So we go in that direction. Does that make sense? And the reason why we had to have this here is because you can see we get ever so close to that circle there. And we really did need to do the graph that way to get ever so close. Because sometimes what happens is students might get this close, but they forget this last part. So does that answer your question? Because that is pretty much how you go about graphing these. That's the best way I've ever figured out how to go about it.
Yes, I understand it a little bit better than I did before, but I guess I'm trying to find a way to understand it a little bit more easier than
I don't think there is a way. Now I did put video links in our course,
Mhm.
in your course in Canvas. And there is the way that, let me see if I can get back in here. And this is Canvas here. Can you see this? If I go to okay. So if you look at this announcement here, this may help you more depending on how you learn. Test 2 required written work topics. You might, oh, they don't have one here. They do have a video, and I think it's in our course, actually. Did you take a look at this one? Let me go to Alex, because this is in our course, I believe. Those were the written work. Oh, those were the written work required topics, not, and this is not a written work required topic.
No.
And so I did not want to make it that way either. So, and it's worth 5 points. I didn't want to make it worth a ton of points either. So that's why I chose not to do that. But let's go into our
Yeah, because I found every objective except the piecewise function and the one, and one more, but it was the one that was due this Sunday. It was, I think it was inverse functions. I forgot what it's called.
I'm going to look in the student view here because I want to see if I can find the piecewise defined function one for you so we can so let me know. Let's look at start my path here. Let's see, which topic are they? Okay, test. Let's see if they've got the piecewise one. Yes, here's the piecewise. Oh, that's evaluating a piecewise defined function. That's not what I want. Graphing a piecewise defined function one. Okay. And it's a locked topic. That's because I'm in the student view. So I would have to actually go back. I believe, though, that there's another place that I can look for you to see. If I go into this, there should be a video over to the side because it's a really good different way, and some students learn better that way, of video. So it should be available. Can you get into your Alex software? I just want to make sure the video is there for you, but I will take a look on my side right here and in my instructor course here.
Yeah.
And let me take a look at class administration here and class summary, and I will go down and see if make sure that it's connected there in the piecewise defined function. There should be a nice little video that was put out by Arizona State University. I think it was in Lines Part 1, actually. Yes. Yes, there is a video here.
No.
It's a 6-minute video. So you may like graphing a piecewise defined function problem type 2.
We are given a set of equations which correspond to rays on a graph.
So if I come back here, let me see if that if what happens if I go up here.
3x plus 1 if x is less than -2.
And I.
And 1x minus 3.
There's the. Do you see how I put the link to it in the chat?
Let me see.
Equations revolve around x being less than, greater than, or
Oh, I
equal
don't see it.
-2.
Do you
Does
see
this
it?
mean that we need to input
No,
-2
I don't see it in the
x
chat.
then solve the equation to find the corresponding y coordinate?
Do you see it now? I forgot to put the. I forgot to enter it. Okay. So see if you can get to it. Let me just turn this off so it's not so much. Can you get to that?
Yes, I can. I'm on the computer.
Can you see if it
In this
talking about piecewise defined functions?
Yes, it's problem 2, type 2, and it's the one I do tomorrow for the. Because I'm on the Alex right now. It says I've done 24 of 25 topics.
I
just-
see.
yeah.
So will that help you, you think?
Yes, probably.
Yes. So you try that
Mhm.
or the recording. Let me turn off the recording for this one so that you can also, I will also make sure, stop the recording.